If I have two charged particles, whose charges are Q1 and Q2 respectively, separated by some distance r, then I can calculate the electrostatic force experienced between them using Coulomb's law, which states that the force is equal to K times Q1 Q2 divided by r squared. Here, K is a constant known as the Coulomb constant, whose value is equal to 8.988 into 10 to the power 9 Newton meters squared per Coulomb squared. If the force is positive, then that indicates that the two particles have the same sign of charge, which means that the force will be repulsive. If the force is negative, then that indicates that the particles have opposite sign charge, which means that the force will be attractive. As an example, let's consider two charged particles of opposite sign of charges 3 coulombs and -4 coulombs respectively. Let's say they're separated by a distance of 12 meters. Using Coulomb's law, we write F equals K Q1 Q2 by r squared, and we can substitute in K Q1 Q2 and r. Notice that the units will end up canceling to give us only newtons. Plugging this into a calculator yields -7.49 into 10 to the 8 newtons. As the force is negative, this indicates there will be an attractive force. Notice that both particles experience the same force F, regardless of their charges or masses. This is due to Newton's third law, which states that these force pairs are equal and opposite in magnitude and direction. Let's try another example. This time I have two negatively charged particles, both with -1 coulombs. And they're separated by a distance of 100 meters. Now we write F equals K Q1 Q2 by r squared and substitute K Q1 Q2 and r. Plugging this into a calculator yields 8.988 into 10 to the 5 newtons. As the force is positive, it indicates that the particles will experience a repulsive force.